Hello everyone, welcome to Aravalli Geo Academy. Today I'm going to discuss about 5 important PYQs. Those are very important for CSIR-NET, GSI, GATE as well as IIT JAM. So let's start. First question is, 1 minute, I just take my pen. Okay, first question is the presence of Hamuki cross stratification unit indicative of which depositional environment? Aeolian dune, deep marine turbidites, storm dominated shallow marine deposit and fluvial channel. So Hamuki cross stratification is the indicative of storm dominated deposit. Okay, this is the picture of Hamuki cross stratification. Here the elevated parts are hummock and the soils are the depressed part. Okay, and in the Hamuki cross stratification, in the bottom of the bed, soil mark also present. Let's talk about Hamuki cross stratification in details. So it is a sedimentary structure which is very storm dominated. Okay, and unidirectional flow also present. Next is Hamuki cross stratification occurs between fair weather and storm weather wave base in shallow marine setting. Next, it is characterized by low angle undulating lamination forming hummocks and swell. Hummocks are, as I said, that it is elevated part and swells are depressed part. Okay. Next, Hamuki cross stratification is the key indicator of Thames-tide deposit and storm-dominated environment. Next is fine to medium grain sandstone is most common lithology exhibiting Hamuki cross stratification. This is all about Hamuki cross stratification. Okay. Then next question. Which of the following equation correctly represent the Froude number, where G is the gravitational acceleration, H is the depth of water, V is the mean flow velocity. So Froude number Fr is equal to V by Hg, root over GH or Hg you can say. So what is V? V is the mean flow velocity or water flow velocity and GH is the gravitational wave velocity. So Froude number is the ratio of mean flow velocity by gravitational wave velocity, and Froude number, when Froude number greater than 1 it represent upper flow regime, and when Froude number less than 1 it represent lower flow regime. If you want to know about Froude number in details, you can comment me, I will explain. Okay, so correct answer is option 1. Next is, which of the following oblate shape of particle in the zinc shape classes, where A is the length, B is the breadth and C is the thickness. Okay, so B option, here the 4 option, option 1, option 1, 2, 3 and 4. Before going to options, I want to show you what is this zinc shape classes. Okay, so this is the zinc shape classification, where tabular or oblate, equant, bladed and prolate size grain present. So when we call tabular means where B by A, B for breadth and A for length. So when B by A greater than 2 by 3 and C by B less than 2 by 3, you see this is the 2 by 3 line, this is the line, and so when B by A, this is B by A, so B by A is greater than 2 by 3 and C by B, this is C by B, and this is the 2 by 3 line for what I say, this is the line. So this is the C by B, when C by B less than 2 by 3, then what happened? Tabular form occur. See, this is the tabular, this is the tabular. Next, oblate. In the case of oblate shape, B by A greater than 2 by 3, okay, and C by B less than 2 by 3, okay, as well as this tabular or oblate, same. Next, for equant, b by a greater than 2 by 3 and c by b also greater than 2 by 3. You see, this is the 2 by 3 line and c by b also greater than 2 by 3. Okay. Next is the case of bladed. Bladed, b by a less than 2 by 3. This is the bladed. So b by a less than 2 by 3. Here the 2 by 3. 2 by 3, b by a less than 2 by 3 and c by b also less. Both are less for in the case of bladed, and for in the case of prolate, b by a less than 2 by 3. This is the 2 by 3 line, b by a less than 2 by 3 and c by b greater than 2 by 3. This is 2 by 3 and c by b greater than 2 by 3 in the case of prolate. Now you come to the question and tell me what is the correct answer. So obviously b by a less than 2 by 3 in the case of oblate shape and c by b greater than 2 by 3. This is the correct answer. Okay. So next question. The Joule-Storm diagram shows that fine-grained sediment require which of the following to re-erode compared to the coarse grain sediment. First option low velocity, second high velocity, third the same velocity and fourth no velocity threshold. So before answering this question, I want to show you the diagram. So this is the diagram. This Joule-Storm diagram, I already explained about this diagram in previous. No worry, I also discuss now. So here you see above mean or critical erosion velocity, particles are eroded. Okay, and below the mean flow or settling velocity, particles are deposited. Okay, and this is the particle transported field. And you see, now you check for fine and for coarse. So fine means clay silt size, coarse start from sand, gravel, pebble, cobble, boulder. Okay. So you see, you can check this line. So if you draw a line about from 100 semi per second flow velocity, okay, then what happened? Clay and silt have very higher erosional velocity, then you can find that sand, gravel very low. So from this diagram we can say that for fine grain sediment required very high velocity to re-erode compared to the coarse grain sediment. Okay, come to the next question. Which of the following is the process to redistribution of material within a sediment leading to segregation of the minor constituent into nodule, concretion, etc.? So first option is diagenetic reorganization. This is orthogenesis. Orthogenesis means within the basin. And second option is diagenetic differentiation. Third option is diagenetic metasomatism. And fourth option is intrastratal solution. Okay. So let's talk about each option one by one. What is diagenetic reorganization? Okay, so this is refers to the changes that occur in sediment or sedimentary rock after deposition, excluding metamorphism and weathering. This next is diagenetic differentiation. Diagenetic differentiation refers to the process where mineral or rock compounds undergo distinct diagenetic changes and segregates. Okay, in diagenetic differentiation what happened? Mineral segregates. Next, diagenetic metasomatism. In diagenetic metasomatism, what happened? Here, the chemical alteration of sediment occur. Metasomatism means alteration, na? So here chemical alteration occur for this case. And in the last, that intrastratal solution, where the dissolution of mineral or rock components within a sedimentary rock occurs after deposition and before diagenesis. Okay, this is undergone what? Dissolution. So my correct answer is option 2, diagenetic differentiation. Okay, so this is the 5 question. Option 2 is correct. Okay, thank you for watching this video. Have a nice day. Jai Hind.